Okay, YouTube, in this video we're going to be working on writing rules for transformations of exponential functions. That is to say that we've been working a lot with giving a rule for a transformation of a function and going and graphing it. What we want to do is use what we know about transformations of functions to write our own rule to match that function. So what we're going to look at is a series of descriptions here followed by tasks where we have to write a rule G that is a transformation of f. And so let's go ahead and start with what I want to point out here, which is that f of x, often f of x is some function that is given to us, and so I'm going to write a given function. But I'm also going to write that we often use f of x to indicate the parent function. And so we say that the parent function is basically the most basic form of any function, that we memorize any of its characteristics, and then we go and make transformations of that parent function using some other designation, typically g of x. And so with respect to what we're going to be doing here, we're going to say g of x is a transformation, okay, transformation of the given function. So I'm going to say of f of x, generally speaking. But what we want to do is basically be able to write a g of x for some given f of x. And so the way we have often been writing these, and the way I'm going to represent it here, is this. We say that g of x, which is our transformation, is just some f of x where we've taken it times a, we've subtracted or added on h off of or onto its x value, and we subtracted off or added on k values to the entire function value afterwards. And so what we've seen up until now is that our h value here is our horizontal, okay, horizontal shift, is also referred to as a translation. We say that our k value is our vertical shift, okay, and then we see that a is vertical stretch and shrink, okay, and I'm going to be specific here, by a factor of whatever a is, okay. So when we look at this here, there are the transformations we certainly have seen, things like this. If we have a negative in front of our x value, we have a y-axis reflection. Y-axis reflection. Let me try to spell this here. And if we have a negative in front of our y value, like this, we have an x-axis reflection. We have these transformations. But what I want to basically focus on are a, h, and k more generally speaking. So keep these in mind as we write these transformations, but let's take a look at how we could write a function g of x in terms of f of x if we know the transformations and then come up with a rule. So looking at this, it says let the graph of g be a reflection in the x-axis, and so we can see we have an x-axis reflection here, followed by a translation 4 units right, okay, of the graph of f of x equals 2 to the x. And so one thing we want to acknowledge is this. F of x equals 2 to the x, this is the parent or given function. And so what we're going to be doing is we're going to say that g of x in terms of f of x, because what we want to do to f of x is this. We want to reflect it over the x-axis. So what would that mean in terms of our transformations here? Well, I suppose that it would mean if we want to do an x-axis reflection, we have to make our y value here, we have to make that negative. So we would put a negative out in front of our f of x here. So there would be our x-axis reflection, and we would have a translation 4 units right. So when we look at 4 units right, this would be a horizontal shift, and our h value in here, this, okay, would have to say x minus a positive 4, which makes this look like this here. So we would say that g of x, generally speaking, we'd say is a reflection over the x-axis by putting the negative out in front of our y. And we say it would go 4 units right if you made your h value a negative 4 there. So what would this look like in our function? Well, because g of x really is negative f of x minus 4, then we would say that because f of x is 2 to the power of x, 2 to the power of x now becomes this. We would see that we would get 2 to the x minus 4 here. And this negative, the way we would apply this, it would be situated out in front. So what I want you to see is that generally speaking, we would see that given any function f of x, g of x could be written as an x-axis reflection in 4 shifted units to the right by saying a negative out in front, okay, and a negative 4 in here with our x. But what I want you to see is that we could really just look at this really as some a value times 2 to the power of x minus some h value here, okay, it's h, plus some k value here. So filling in what we know, I suppose we would say that we would want to put a negative out in front of this to reflect it, And we would also say that if I wanted to go 4 units to the right, it would look like this. So our final function, g of x, simply put, would be reflection over the x-axis by putting the negative out in front and just saying x minus 4. Yes, all of that talking just to say, hey, this takes you right 4, this takes you over the x-axis. So let's take a look at one more here. And this would be, I believe, with logarithms, but we want to write a reflected function here, transform function. We'll go a little bit more quickly. So it says, let the graph of g be a translation 2 units up followed by a vertical stretch by a factor of 2, okay, by a factor of 2. And we say that the graph of f of x here, which is y equals log base 1/3 of x. And so one thing I want to point out here is that our parent function, okay, let's write this in as y equals log base b of x, but our transformation, generally speaking, is going to look like this. We're going to say a times log base b of x minus h plus k. So you can see that our h value is in here with our x quantity, k is a loose constant on the outside, and our a value is out in front here. So if we're going to write g of x here, they're going to say g of x, okay? It is a translation 2 units up followed by a vertical stretch by a factor of 2. Well, let's do our vertical stretch first. We would say that vertical stretch, we would have to put our 2 out in front here, or multiply our y values by 2, and then we would say we're shifting up 2, we'll put a k value in here, plus 2. So in terms of what this would look like in our function, we know that we have log, okay, base, in this case, 1/3 of x. We see that we would have log base 1/3 of x. This plus 2 on the outside would shift us up 2, and this times 2 out front would be our vertical stretch by a factor of 2. Cheers.